we begin trigonometry, what we're looking at is the relationship of the acute angles of a right triangle and the ratio of their side lengths. For every acute angle in a right triangle, so those are the two smaller angles in the right triangle, there is a specific value for the side lengths that create that angle. And we define those ratios with three functions. First is sine, which is abbreviated SIN, cosine, which is abbreviated COS, and tangent, which is abbreviated TAN. Okay? And each function has a specific set of sides in the right triangle that we use. So the first step to solving any trigonometry problem is to first label the three sides of your triangle either as opposite, adjacent, and hypotenuse. Okay, now when we label those sides, it is in reference to the angle specified. Okay, so for this particular example, we're looking for the value of the sine function for angle C. So this is angle C. Okay, so that's what we consider our reference angle, because everything revolves around that particular angle. So when I label my triangle, it is from angle C. So the opposite side is always going to be directly across from the angle itself. So this will always be my opposite side. Now, the hypotenuse never changes. The hypotenuse is always directly across from my right angle. And then by default, the remaining side that isn't labeled is the adjacent side. Now, the sine function, so the sine of any angle, and that funny little symbol that I just drew in red is what we call theta. That's the Greek, it's a Greek letter, and it represents angle. Okay, so the sine of any angle is equal to the opposite side divided by the length of the hypotenuse. Cosine of theta is the length of the adjacent side divided by the hypotenuse. And the tangent of any angle is equal to the length of the opposite side divided by the adjacent side. Okay, so if we notice here in number 5, we're looking for the sine of angle C. Well, sine is the sine of angle C is equal to the opposite side divided by the hypotenuse. Well, my opposite side has a value of 20, and my hypotenuse has a value of 29. So this is the value of the sine function for angle C. Okay. So we could also find the cosine and tangent of this triangle as well, because we're given values for all three sides. But when we're just looking for the ratio or the value of the function, that's all we're looking to do. We're looking to write the fraction. Okay, now if I slide over to number 6, here we're looking for the tangent of angle X. Okay, well, angle X is here. So again, first step in any trig problem is to label your triangle. So directly across from my angle is always my opposite side. Across from the right angle is always the hypotenuse. And then by default, we have the adjacent side. Now, the tangent of x, based on the definition of my function, is the opposite side divided by the adjacent side. So to find that value of tangent x, I'm just going to fill in the values of the opposite side, which is 36, and the adjacent side, which is 27. Now, you may see this as a smaller number because I can reduce this fraction because they're both divisible by 9. So this would also equal, if I reduced it, a value of 4/3. But so that's all we're looking for in this particular case. We're just looking for the value of the function, and that is the fraction. And then to show an example of cosine, we have cosine of z. So z is here. So opposite, hypotenuse is across from the right angle, and adjacent. Now adjacent is always the side of the triangle that helps form that angle. But it can be tricky to identify, so that's why I always label the hypotenuse and opposite sides first. So cosine, by definition of the function, is the adjacent side divided by the hypotenuse. So cosine of z is 20 divided by 29.